Talk to Bitcoin.
Always down.
Take it easy. You know, like
Saifuddin is the imam of Bitcoin. The Grand Mufti.
Cool. So we'll do like a 45-minute fireside chat, and then there'll be like an hour to hang out again and kind of keep chatting. Cool. Well, thanks everyone. This is actually a complete experiment. I'm looking to just lean into the San Francisco energy. I still think San Francisco will be the future of tech, so I figure we'll do our part as AngelList to contribute to it. And of course, you're the first. This is great.
This is I'm the first.
You're the first.
That's an honor.
Exactly.
Thank you.
Well, cool. Well, I want to start by introducing Amjad. He's the founder and CEO of Replit. And so I took a look at your background and listened to a lot of podcasts recently, and you've spent a lot of time just thinking about building software tools, right? Founding engineer at Codecademy, and then you were Facebook for a bit, and then did Replit. I'm curious, why dedicate your life to building software tools, building tools for creators?
I think developers are sort of the modern day alchemists, if alchemists ever existed, but like modern day magicians, whatever you want to call it. It's just like this huge superpower. And for me, software changed my life in fundamental ways. Growing up in Amman and basically was pretty poor growing up, but was able to make money pretty early on. Even as a preteen, I would format computers and install Windows and do all sorts of things like that for change. But then I wrote a piece of software when I was 15 that I sold for hundreds of dollars, and that was I was at some point probably making more than my father.
Mm-hmm.
And then I wrote some open source software that got me my job in the United States at Codecademy. And I came here to the US, and just going through that journey, it's just absolutely mind-blowing what's possible. Like, for the first time in history, we have this thing that's truly the great equalizer. They talked about literacy in the past as the great equalizer, where anyone can contribute to human knowledge, right? But the internet and software is truly that. Like, nobody cares who you are, where you're from, what your background is. You can write good software, and you can demonstrate that. You can demonstrate that on Replit. You can demonstrate that on GitHub. Then people will take you seriously. And so for the first time, we have this superpower. And the frustrating thing about it is that it is not very accessible. It is not easy to get started. It has been getting less fun over time. So if you look at the early programming environments like BASIC, when you booted up the Commodore 64, you just boot it up into a BASIC interpreter. And the first thing you did is type a command and run a program, right? You could write a piece of game or something like that. It actually came with a manual with a bunch of games you could write. And using computers was fun because you could program these machines just as soon as you bought them. Today, you buy the most ubiquitous computer you could buy is a mobile device, right? It's Android or iPhone. Let's say you buy an iPhone. Okay, that's a $1,000 device, and then you're like, okay, how do I program this thing? How do I use it in the way God intended for me to use it? Actually, command it in a way that's the highest agency way to use a computer is to write software for it. So then you have to buy a $2,000 MacBook, and then after you pay $3,000, you have to pay Apple $100 a year in order to give you kind of permission to write software for it. And by the way, this is what I did at Facebook. I worked on React Native. I was one of the founding engineers there. And the idea behind React Native was to open up the mobile platform to make it more accessible, to get more people to write software on it, make it more fun and exciting. And so all these reasons, I think it's a superpower. I also think it's a huge equalizer. I think it's a huge economic boost to everyone in the world and to the world itself. And so I think that's why I think software is such a powerful thing.
Yeah. Yeah, you've actually done something really interesting with Replit. You allow people to code on their mobile device, and you just did this recently, which I thought was like just absolutely mind blowing. I wouldn't have thought of it. And it really sounds like you're doing that because you're coming from, you weren't born in the US. I was actually born in the Middle East myself. And because mobile device is more ubiquitous than laptops, you think that will be the next development paradigm. So I'm curious, like, how do you see people developing on the mobile device? Like, because you typically need this, at least I would think about, you need this big screen, multiple monitors, this whole setup, yet you're actually shrinking the form factor.
Yeah. So actually, we just crossed 10,000 DAOs yesterday on the phone. There's
Wow.
10,000 people around the world.
Wow.
And the app is like 3 weeks old. So
Yeah.
it's like writing code and running it. You're one of them? Nice.
You're writing it right now.
So actually, like in school, I had a Symbian phone. And the first, like, Symbian is like the Nokia phone. It's like the first time you could like feel like there's like a computer in your hands. And the first Replit kind of prototype that I wrote was basically a text box where you can type a bit of JavaScript. There's a submit button. It basically takes the text box and evals it and then alerts it. And I had like this Rebel on my phone, and like I would like go to the website on my phone and would type JavaScript like under my desk as they're like saying some boring shit, I'm sure. and I was coding in class, and it was like such a fun experience on this like really crappy device, and this like crappy interpreter, and it just worked. And it was like really obvious to me. I tried to do as many things on my phone as possible, and again, it was a really limited phone. So when the Android and the iPhone came out, it was immediately obvious that this is going to be the future of computing. And you look today, and people who have kids will tell you that just kids prefer to do everything on their phones. And I think just the form factor is more personal, and it's with you all the time. And so we're still very early. Like I think there's a short-term answer to your question. There's a long-term answer. So let me start with the long term and then go back to the short term. I think the long-term answer is like you'll be able to talk to your phone and for your phone to like generate software. I think that's like a lot of the development that's going to happen in AI. Some of the stuff we're working on is that you'll be just talking to this assistant that's going to help you write the software. And probably there's going to be other form factors. I think AR at some point will be a thing. Or some kind of projection or whatever people are working on. I don't think mobile is like really the final form factor, but I think some form of mobile will be used in making software. The other thing is like it's really accessible. Like anyone in the world with $100 can like buy a phone, and at minimum, even if you want to invest in a device later on, at minimum you'll be able to learn a bit of coding from your phone. Now, just more short term, before we get these AIs, I think there's a lot of UX innovation to be done. Like, so if you've tried our app, we ship with a joystick. The joystick is actually ASD aware, so meaning it knows the structure of the code. And as you're navigating, it has this intelligent places where it goes around in the code. If you double tap on the joystick, it highlights the keyword. If you double tap again, it highlights the line. If you double tap again, it highlights the block, and recursively, so on and so forth. And this is like one engineer's work. And I feel like on mobile, there hasn't been a lot of UX innovation, like even just natural language input, like, since 2007, essentially, no one has done anything there. And I think there's so much we could do on just like making like input a lot better. And then Ghostwriter is our current generation AI. I would say it probably saves you 50 to 60% of your coding, especially on your phone. Especially people who get really good at prompting it. You can basically just chat with it on your phone. So even the future kind of AI thing that I just like talked about, actually some people are doing it today. So just in comments, they're directing the AI what to type. They'll look at the suggestion from the AI, they'll either accept it or they'll change the comment in order to tell it to do something else. So I think we're going to have a lot of innovations on how we do input, but I also think just people will go from, doing a little bit of coding, learning coding on their phones, and then getting access to a computer. So the question is like, how do you go from your phone to getting access to a computer? It's a more expensive thing.
Yeah.
One idea is that maybe you could do a bit of work from your phone and earn some money to get a computer. We just announced last week this thing called bounties. So bounties, you'll be able to, any one of you will be able to post a software task on Replit, and people from our community can go and like write software for you and earn money. And we think people will be able to do it from their phones. So you learn for a month on your phone, and maybe you'll be able to pick up, and maybe some tasks will just like classify them as like phone only tasks or something like that. And you'll pick up some like tasks and then start, accumulating capital, and then buy laptop and so just level up as a software creator.
Yeah, fascinating. So it's actually a perfect segue into Ghostwriter. Ghostwriter is actually what pulled me back into coding again on Replit. And I just found it fascinating. And it was fascinating because for me, I just have like a certain window where I can actually code. It's over the weekend. I was trying to do something. I'm like, fuck, I don't have time to go through Stack Overflow and Google. And then I saw your tweets on Ghostwriter. I'm like, all right, let me give it a shot. And I was just blown away. I mean, it truly has changed the way I code. And what I want to do is actually want to spend a bit of time on how that happened, right? Is you start with a large language model. How the hell do you take it from that to Ghostwriter, right? Like, what was the journey there at Replit to make that happen?
Yeah, for sure. So, large language models have been the property of large AI labs, part of like trillion-dollar companies, right? And for a while, it just seemed like, okay, you're gonna have to, call this API somewhere. And we weren't really comfortable with that for a variety of reasons. But one of them is like, we're actually really good at optimizing compute. Like as a company, Replit's core competence is to optimize compute. Like we give free computers, basically we're in the business of giving free computers everywhere in the world, right? And so we got really good at like building multi-tenant systems and building low latency computers in the cloud. And so we're like, okay, like there must be a way for us to do that in-house. And we started looking at some of the open source models. A lot of the open source models that came out that were like kind of like GPT-3 were very large and very slow. Like, if you try to run, one of these 100 billion plus parameter model, it would take like on a standard GPU, it will take like 60 seconds per inference. So like we want something to be not only sub-second, but like I think it should be like maximum like 400, 500 millisecond. Anything more than that, it will take you out of flow. So then we found, Salesforce released this model called CodeGen. And CodeGen was really great, some of the best models we've seen. It has a few problems. One, it was super slow. It was still like 30, 60 second inference. Two, it was like larger than we needed for our use case. Three, it was the quality was not great as much as we'd like it to be. And so we're like, okay, but this is like a great base for us to start with. So the first thing that we did is we just rewrote the entire thing. So like a lot of ML models are very inefficient. They're written in Python and things like that. So rewrote the entire thing in C++ and kind of fix it up, make it a lot faster. We got 2 orders of magnitude speed up.
From going from Python to C++.
And some other optimizations.
Right.
I think we also changed the architecture of the model to run faster. And that was like 2 orders of magnitude speed up. And then another like more marginal on the order of like 50% speed up was streaming. So instead of like waiting for the entire response from the GPU, you just like stream the tokens as they come. This also like gives you like as the user using it less perceived time. So you might have seen Ghostwriter will like give you a line, and then if you're waiting, it'll give you more. And the other thing we did is batching. So we batch so we can do like multi-tenant systems. So right now we have about 2,000 DAUs on Ghostwriter. It's a paid product, so it's not as big as the our other products, but it's growing really fast, and that's running on 3 GPUs only. So 3 GPUs running all of that stuff, and we think we can like add more users and just be on 3 GPUs. So we think it's like
got it.
It can scale. It can scale a lot, and we have really healthy margins on that product. And then the final piece was the front end. So we got the early optimizations. We were like really excited about it, and then turns out that like the front end component is actually very tough. So it might not seem like it's just like text complete, but for example, you get a completion from the server from Ghostwriter, and the completion has let's say a closing bracket in it, but you already have a closing bracket, right? So how do you, if you add now like you're in the middle of a line, or you let's say you're in the middle of a parameter list, and you want to get the parameters completion, but you don't want to get the closing bracket. So you have to strip it out at the front end, and you have to do a lot of like bracket matching, a lot of AST stuff on the front end. So we spend, so like most of the optimization work was done in like 2 weeks, like 3 or 4 weeks. We're like training the model on more tokens so that it's better. And then during that time, we were just like building the front end. But end to end from product to from idea to product was like 8 or 9 weeks.
Oh wow, that's amazing. I've also heard you talk about, so that's one application of large language models when it comes to software development is basically code completion, or you can get code blocks. You've also talked about anomaly detection, right? So you can kind of go through code and see if it's written correctly or not. Is that something that you're pursuing with Replit, or because I found that also a very interesting application. At all times, let's kind of detect it and find bugs ahead of time.
Yeah. So we sort of shelved that project because it just needed more effort to get. Typically, the 80-20 rule, you get like 80%, but then the 20% are really hard. But the idea behind it is, like errors are anomalies, right? So when you have a piece of code, if you run it through a model that's trained on code, and the model gets sufficiently surprised on a certain token, there's a high likelihood that the token is an error. And we found that the model has good, let's say, intuition about not only syntax error, which are easy, but it actually knows logic errors as well, that was like really surprising for us. So basically, you take a piece of text, you look at the probability distribution that the model thinks every token has, and if there's something really out of the distribution, then the likelihood of an error is really high. Now, there's a lot of false positives. So we built another learned layer to kind of suppress those false positives based on user feedback. But that part required a lot more work. So we want to revisit it later. But I think that the meta point here is that large language models have a lot more capability than what people think you can use them for. Most people that think, oh, you prompt GPT-3, it does something interesting. But actually, you can build a lot of different applications with it. This anomaly thing could be used for fraud detection, could be used for a lot of different things.
Yeah. So let's zoom out now, and let's go 10 years in the future. What do you think Ghostwriter becomes? Is it truly just you tell it code this program and does all of it?
I don't know if it's like, I think that some part of it is gonna be fully like that. I think it'll be. So the way I think about it is, like last century, since programming started, right? Like, what was it, like 40s, 50s? First, like people were interacting with machine code. Like literally some computers, you could like program them using binary. And then you had like punch card, which is like a little bit better. Then you had assembly, and that was like the first time you had like language. You could like write programs in, and you could write libraries, and people could collaborate on that. That was a huge improvement. It was like 100x improvement over machine code. And then you had C and C-like languages, and that was another 100x improvement over assembly. And then you had the scripting languages, like late 90s, you had Python, JavaScript, Ruby. That's probably not 100x, maybe a 10x improvement in productivity. And then the one last improvement in productivity we had was open source.
Mm-hmm.
Open source was not a language improvement, but it was a sort of package improvement. So instead of writing all the software yourself, we can share software packages. That's probably another 10x. Since then, we haven't had a 10x improvement in software, right? Like even Replit is probably 2x improvement. And it's like, okay, well, obviously something will happen. We're going to get more, like people just think, oh, this is software, it's been happening the same for like 10 years. It's going to stay the same forever. Like I think this trend will continue. So what is the next big productivity improvement in making software or for programmers? I think it is AI. So I think Ghostwriter and Copilot today, it's like 30, at best 50% productivity improvement. Some people say it is 50%. I think the people who know how to use it or prompt it. What we see at Replit is like consistently 30% improvement. Well, like any task that takes you like 10 hours might take you 7 hours with Ghostwriter. But that's like a not multiples, definitely not an order of magnitude improvement. I think where AI goes next, but this is the early sort of innings of it, is more embodied AI. So today, when you're working with Copilot or Ghostwriter, it's like you're coding and you're calling your friend on the phone, your friend, the super knowledgeable programmer, and you're yelling keystrokes at them. F, space, D. And they're yelling back suggestions. And they're going to predict what you're going to write. They yell back suggestions. And every now and then their suggestion is a good thing and you'll just type it out, right? Or you hit tab. So that's basically the interaction. What I think will happen is the AI will instead sit on a computer and be in a multiplayer session in Replit with you. Mm-hmm. And so what that means is they have access to the entire event stream coming out of the IDE. So that means they'll see every output, they'll see every event, they'll see your edits as they're coming out, they'll see your chats, they'll see your debug sessions, your REPL sessions, your maybe documentation lookups. And they're going to be trained, instead of text distribution, they're going to be trained on events and actions. So it's going to be an action model. So it's going to be hooked up to Replit on a multiplayer session. And I think the first product we'll build on top of that is that it will predict what you want to get done and offer it for you. So, maybe you're refactoring a file, and as you're doing that, we're feeding your event state as a prompt to the AI. And then when it produces something that we think is useful, maybe it will tell you, hey, we're noticing that you're splitting this file into 3 modules. Like, do you want to get it done? You hit OK and it just gets done. Mm-hmm. Or you hit an error and you get an error in the console, and next to the error says fix it. and then you click fix it, and the AI will iterate on it to fix it for you.
Mhm.
And it will do it in a human-like fashion, where it will like change some code, run it again, maybe get a syntax error, to change some code, run it again, do TDD and run tests for you.
Right.
So we'll like do development like a human will do, and we'll
Mhm.
continue to give and get feedback. And I think that the next step after that is to give it a natural language prompt. So to say like, hey, I want you to refactor this class into 3 different classes, and they need to do X, Y, and Z and whatnot. And then I'll go do it. And if it runs into a problem, it can kind of give you feedback. So there's some dialogue-based agents there that you're talking to. And maybe you don't have just one, maybe you have 10, maybe you have 100, maybe you have 1,000 agents.
Mhm.
So now programmers become levered so much, right? Like it's like you have 100 people working for you, essentially.
Yeah.
And if you think back to my idea about bounties, by the way, bounties data set is going to be very useful for this, but also like every programmer has access to an army of AI agents and an army of developers.
Mhm.
So I think that's like 100x minimum improvement in development this decade.
Yeah, that's wild. So that's interesting that you'll get 100x improvement per developer. And the mission of Replit is also to make many more people into software creators. So where does the world go? I mean, do you have a lot of, software creators, millions, maybe even billions, that are just backed by hundreds of developers themselves? And what does that turn into in the future?
So I think just like from first principles, the computational universe is much bigger than the physical universe.
Mhm.
It's actually infinite, right? So there's never going to be enough programmers to explore the computational universe. And so, just from first principles, there's never going to be enough programmers.
Say more.
If you think about the digital world as a universe of its own, it's way more open-ended and
Yep.
Like anything can be done in it. It's like sort of like the multiverse of the digital universe, right?
Mhm.
Or the infinite. So a lot of the what people talk about in like when they're thinking about like the infinite universe is like anything happens, or the idea of like the multiverse. Similar thing in the digital universe, like really anything could happen. You can write software to do anything, to simulate anything, to create simulations of entire planets or people, to create AI agents, to create different consciousness, to create different art, it's like truly infinite universe.
Mhm.
And so like I think just the idea of being able to make software is such a fundamental thing that everyone would want to participate in it,
Mhm.
and everyone would need more and more of it. I think it's one of these things where like energy has this property where like the more energy you create, the more energy people want to consume. Which is like why like a lot of people that want to reduce energy usage are wrong, because like humanity is about increasing energy usage. Like we should be building Dyson spheres around the sun, right? It's like our calling and our birthright, I think, as a humanity is about doing more and increasing and building more and growing as a species and intellectually as well. So I think it's just like from that point of view, I think we'll always need more developers, and everyone would want to participate in the digital world. Like you can call it the metaverse, whatever you want to call it.
Yeah.
Like people would want to make things in the world in that digital world.
Mhm.
So that's why we'll always need more developers. In terms of so how the distribution will work, I think I think professional programmers will have their place and they'll grow. Maybe it's 100, 200, 300 million programmers, but there's going to be countless others that's going to be in the middle. Like maybe the product managers, the designers will also be creating software. We're going to have the independent entrepreneurs. You see a lot of these micro SaaS entrepreneurs online. It's incredibly inspiring. And they all know like a little bit of HTML and CSS, and they use code in this very utilitarian way.
Yeah.
They'll like, don't think about like the best Webpack library to use. Like they don't give a shit about that, right? That's still incidental for them.
Yeah.
And so you're going to have a lot of these micro entrepreneurs like making software. I think like scientists will use software a lot more. I think artists will be able to use software a lot more. So with the idea of a software creator just expands. And you see that in other areas. For example, like Figma expanded the concept of a designer.
Yep.
AngelList expanded the concept of an investor.
Yeah.
Like without AngelList, I would never have like even thought about doing angel investing.
Yeah.
I think a lot of what software is, and a lot of what is great about Silicon Valley is about this idea of access and just like taking something that was like elite status and making it more accessible to people.
Yeah. Yeah, that's really fascinating. I'm curious, outside of software development, what other areas you think large language models and AI generally is going to impact? So we have one, software development, like what are the big other things that people are not talking about today, but you have high conviction in that it's going to just change things 10 years, 20 years, 50 years from now?
So I do think that, good point. I do think that let's call it value on the internet or payments on the internet I don't want everyone's mind to go to like the current crypto hype or last year's crypto hype, but I think we can go there. I think that like even AngelList is a way to move capital on the internet, right? Do you think about it that way?
Yeah. So you move capital and then you get ownership, but specifically within productive assets.
You trade, you create ownership. You create alignment on the cap table. It's about like, it's about capital and entrepreneurship on the internet. And I think that's really, really exciting area in the internet in general. I think enabled by Bitcoin and Bitcoin Lightning is going to be a super fascinating area in the future. I think a lot of what's happening in crypto is a huge distraction. Like I wish it really like wasn't like a lot of the FTX stuff, a lot of the gambling and the casino stuff, just a bunch of crap. Like the core idea is that now we have a native value exchange protocol on the internet that's fully decentralized and not owned by anyone. And that's really, really fascinating. I think that on the question of LLMs and what areas that are going to be applied on, I think basically every software will get more intelligent. I think basically literally every software you're going to interact with will have some form of intelligence in the future. Like the way AI has worked in the past is that anytime AI became ubiquitous, we stopped calling it AI.
Yep.
We started just calling it computers or software, right? And so it will be really exciting to see how we apply AI and LLMs into biology. I think a lot of biology is language. Like DNA is obviously a language. I think you can model these things pretty easily. Tesla and their AI day talked about how they modeled traffic as a language, and they have a language model that predicts traffic movements, which is really fascinating. It's really one of those super horizontal things. I think there's going to be a lot of exciting vertical things, but it's really the best way to think about transformer technology is that it will infect everything. It's like a virus, and it will really infect every aspect of software, every aspect of technology. I think search is super interesting. We were talking about search earlier and how you can use the network of value as a way to figure out how to do better ranking. But using large language models for search is a fascinating idea. like one way you could use it. A lot of people are using GPT-3 instead of Google search. A lot of people use Ghostwriter instead of going to Stack Overflow. So I think search where it gives you an immediate answer is going to be super interesting. We'll see how we're going to solve the hallucination problem, because it gives you whatever you want. Google search already has that problem.
Yeah.
You can bias the search as well, but they've done a lot of work to make it better. So LLMs will have to improve. Yeah, it's almost like easier to answer the other question, which is the opposite question, which is what areas will large language model not impact?
Yep. Which I'm assuming is none.
Yeah, I can't think of that.
Makes sense. Great. Well,
one thing I'm interested in though is like, how can we use these things to understand how we work as humans? Like, can we use large language models to understand how consciousness works, how humans learn, that sort of thing? So can you use it in a way, I guess, in a research kind of way to understand psychology better? That could be really interesting. I know there was a paper that used transformers to translate new brainwave activity into language. So basically, you can
that's fascinating. Like, as in, they would just look at brain waves and then be able to convert brain waves into language.
Yes.
You gotta send me that paper.
Yeah.
That's fascinating. Yeah. That's actually wild. There's so much that unlocks from that. Yeah,
including you can spy on people, right?
Yeah.
You can spy on people's thoughts. That's crazy.
Love it. On that note, let's take some questions from the audience.
So I was like one of the guys who learned to code on Replit, all that, and coming into like my first software jobs, like the big kind of gap that I found was like on all the Replit stuff, like I could run my own projects, kind of build all my own software, and then I like come into a 40 million line code base that's a giant monolith, and like how do I kind of work into that? Like, how do you think about like teaching architecture and kind of like using Replit instead of just like kind of do it yourself by yourself, of like building sort of like the sort of commercial aspect if you're going to use Replit to eventually move on for jobs?
Yeah, there's always this tension between building for the future and supporting the past. Like, ultimately, legacy code is the past. So if you believe in half of the things that I talked about how the future is going to unfold and it's going to change, you have to believe that a decade from now, like, all the software that we have today is probably like 5% of the software ever written. There's going to be way more in the future.
Yeah, makes sense.
It's going to be way more software engineers. There's going to be way more code written. And so it's like, for example, like we were talking about Nix, we've been like made this huge bet on this very niche operating system technology, where basically the operating system is the result of an execution of a pure functional expression. So the inputs to the function is the description of the packages, and the output is an operating system, like literally, which is like a wild concept. And we use that, like every REPL is essentially a Nix expression on Replit. And we're putting more and more things on in Nix. For example, even the language description, like all the tools and the debugger and all the syntax will be in Nix. So literally every REPL will be the result of the evaluation of a Nix expression. And you'll be able to change the REPL and configure it in that way. And so can we boot up like an enterprise code base on Replit? We probably can. I think we need to write some like layers where some backward compatibility layer. But I think even more exciting is that, as you're going into your new job, there's probably some new projects that are starting there. You might start a new project. I think introducing Replit at those moments is going to be a lot more exciting, especially like the way you can pitch it internally is just to give you the like enterprise politics. It's like, we're writing this new cloud native project, and this is like a cloud native architecture, and we want to use it because you don't have to like, download your code, work alone on your machine and then deploy it somewhere else. It all happens in the cloud. So I think Replit is going to be really well suited to this cloud shift that's already happening. And I think if we can just like run future software, that's like good enough for us. The biggest bottleneck today is that we're not scalable enough. So we have a 1 gigabyte storage limit per REPL, and that is really limiting. And I'm sure you already hit it, especially anyone doing ML on Replit, which is like it's so TensorFlow, you run out of storage.
PyTorch soon, right?
PyTorch, yeah. So that storage limit is because because Replit is sort of a distributed system, and as you're working with someone else, you might run into these race conditions. And so when we used like traditional like file systems, we would get a lot of corruptions. So we use this thing called ButterFS. ButterFS is really interesting technology, which is like has atomic writes. So every write is like a snapshot. The problem turns out is that once you get over 1 gigabyte storage, unpacking the ButterFS snapshot becomes very expensive and puts a lot of strain on our infrastructure and ends up kind of locking the machines and all of that. So now we're moving to a network storage devices. So you'll be able to boot up like a 1 terabyte project on Replit if you'd like. Now, your other question was that like the education aspect of it, like, like there's the Replit way of doing things, and then there's like your company's way of doing things.
The wrong way of doing things.
Yeah. Yeah, I mean, at Replit, as much like we try really hard not to create unnecessary lock-in, right? So the reason we use Nix and not invented something at Replit is because it is fundamentally open source technology. Any project in Replit you can download and run on your machine. We never want to create sort of this fake lock-in and high switching cost. We want the business to be honest, and like you would choose Replit just because it's a better product. And so anytime we try to do something for you, we also try to expose it. So for example, we have this magical package management system that like detects a Python import and installs it for you, but we show you what's happening, right? And we show you the packages that are getting installed. So I think that's like one way we also got to do education.
Did you say the future of Ghostwriter is more of an embodied agent that understands the context of, let's say, your current task and then does actions? That's a very distinct type of model from like the current standard LLMs. So like, how do you go about approaching that problem? Like, what are the changes that you think are necessary? And like the experiments you're going to
It's actually not that different, right? Like, so the fundamental way to think about LLMs is that it's like the self-attention module from the transformer, and also the training methodology. So that the way they're trained is autoregressive training, where the way LLMs are trained is that like they get a piece of text, like say a paragraph, and then they mask a word. Most of the time it's at the end, but some training methodologies is like in the middle. And then they run the inference and get the prediction for that word, right? If that word is if the probability distribution is right, then nothing happens. If you calculate the loss function if it's wrong, and then you run the optimizer and you train the neural network. That's how LLMs learn the structure of language, which is actually fascinating, right? Like simply by masking like a word or a token, these language models learn the structure of language, they learn programming, they learn poetry, they learn math, they learn reasoning. It's sort of an insanely fascinating thing that it actually works. So if you apply a transformer to instead of language to a set of tokens, the same thing will happen. It will learn about the structure of that tokens. So those tokens might be events, they might be traffic, they might be vision. So vision models are becoming a big thing now. Vision, transformer models. There's also this thing called action models, which is what we're talking about now. So the same thing that creates large language models could actually create models of different modalities. And there's also these multimodal models now, which they're basically trained the same way. The same neural network knows how to do vision, knows how to do language, knows how to do audio, and it's really fascinating thing that it's all the same sort of training methodology.
So you're saying you're just gonna map the input to some token format and the output to some token format, and then use like similar architectures.
Yeah, so LLMs, you have to do the vocabulary. Same thing, we'll have to do the vocabulary for actions and events. At least first pass, we'll see what comes up next. Do you want to pick or should I?
You can pick.
Two questions. First one, wink, wink, pay bounties and sats. Second question, to prevent this from being like a super dystopian world, like imagine everyone has their AI assistant. Do you think that we'll get to a point where you can actually train your model, like you can have your own AI assistant, you can train it on your phone, or will it be more likely that you just have your data on your phone to be able to send it back and forth, hopefully encrypted, and train your models that way?
Yeah, Peter Thiel once said that AI is communist, crypto is libertarian. With FTX, it turns out it's the other way around. Crypto is libertarian. Crypto is communist. And with what we're seeing with LLMs is that like they're getting open sourced and like amazing velocity. Like there's so much innovation. Some new models coming out of open source models coming out of Google, a 3 billion parameter model that's instruction tuned does better than GPT-3 175 billion parameter model. And the way it works is like they're pre-trained models plus a layer of instruction tuning, meaning supervised learning using ground truths. And so if that continues to happen, I think LLM will be an oxymoron because a lot of these models will be smaller and smaller. I think some of them will fit on the phone. Google already has transformer models for Android transcription that runs on your phone, and phones have TPUs now. And so I actually think what's happening in AI is like a huge distributed force. Like the fact that like we're 70 people at Replit, the fact that we're able to build an LLM service is actually like says this technology is going to be more distributed. Yeah.
I think you mentioned that 60
Yeah.
So I think it's impressive. I've been impressed with how fast. I guess my question would be, apart from hiring great people, how do you keep that culture of
Are we streaming online?
It's not live, no, but we are recording.
Oh, okay.
Yeah, so we can always cut this part.
No. I think Silicon Valley forgot how to like do proper performance management. So not only hiring great people, but firing people who are not a good fit. We have pretty high attrition. Like first month, I think something like 30% of new hires either leave or get fired. Some people leave just like it's too hot in here, like and that's fine. Look, I mean, the cool thing about America is like freedom of association. Like there's this trend in Silicon Valley where you go into a company and then you want to change everything about the company and you create activist groups, and it's like, why? Just go create your own company or go join a company that matches your ideology or your way of working. So I think we need to get better at just like getting back to the roots of like finding great fits and great people, and making sure that like when it's not a great fit, just make sure people leave. So I think that's one part of it, and that's partly why we didn't get bloated like a lot of other companies. Another part of it is like, we really care about, like everyone contributing. So we have a great performance culture. We do performance reviews on a quarterly basis. We collect a lot of data on performance. There's like not one metric that you can count. But I think another thing that this like lie in Silicon Valley that you can't measure engineering performance, but you can actually measure. And there's like, it's like similar lie to the 10x lie that there's no 10x developers. They're actually a trillion X developers. Like Satoshi created $1 trillion market. So it's like the range of how productive developers can be is like so huge. And actually, if you go to your company, if you plot even something like number of commits, you're gonna find a distribution where like the like multiple standard deviations to the right is gonna be probably 10x the median. So performance management and like actually trying to get metrics and understand like how fast we're moving and how much people are contributing is important. And they're all inputs. Like you can't be just like automated about it, or like, oh, you didn't produce this much commits, But like everyone laughed at Elon for looking at code, but absolutely, you look at code. What else are you producing as an engineer? Meetings? That's not useful. So that's another thing. And finally, I think we use Replit very effectively for collaboration, for prototyping, for all that stuff. And I think that ends up being a huge productivity boost.
So the LLM is roughly the whole time when taking out structure bias. How do you come up with the especially those times? How do you come up with that? And how do you change it, like test it, how do you test like that we maybe keep because you can mention like another part that I think you said 40% shorter. So how are you getting better job like especially when we're changing market where interest companies are not putting that aspect on it.
Yeah, totally. So the question is, how do you make bets and how do you validate these bets and how do you kill the things that are not working? Especially now in a changing market where we don't have infinite access to capital, like a zero interest market, you want to be more thoughtful with these things. A lot of what we do is like really based on our vision. So this idea of like, I think that's just the tenets of Replit is like a fast collaborative programming environment, a great community, and like a creative economy where people can like earn, and just like productivity tools, including AI, like how to use our economies of scale, network effects to kind of create this flywheel. And so everything that we do is like based on these things. So it's not like random bets. There's a constraining factor. So I think if you don't have a principled approach, you don't have a mission or some kind of way, a lens, then your operating space is so huge that you end up making random bets. So I think that's like one way to think about it. Another way to think about it is like just sequencing, like what are the necessary primitives to build the next thing. So at Replit, we sort of delayed servicing certain segments of the market that are quite profitable, right? Like professional market, and I think we're going to get into it next year because just the product wasn't ready. And so you just have to understand your readiness and like the amount of infrastructure and abstractions that you build, whether they're going to let you unlock the next product. And then you want to move extremely fast and you want to validate ideas. For example, we announced we're doing GPUs a few weeks ago, and we just shelved the project because we let in a couple hundred people in the beta. Everyone told us it sucks. And why does it suck? It's because I can bring in my multi-gigabyte data set. I can't like install these popular libraries. I was like, okay, what's missing there? It's like the storage bottleneck. Okay, we have to go work on the storage bottleneck. Like, we could have spent another months kind of trying to do that, but like you just pivot really quickly towards the thing that actually is the bottleneck. So like a lot of bottleneck thinking. And yes, the changing conditions of the market, you absolutely have to take it into account. Like it is fundamentally different. The cost of capital went way up. So the dollar you were spending in 21 is now 10x more expensive. So now you have to think about capital allocation a lot more explicitly. And so we're getting better at like finance and control and like trying to understand where the money is going. We're spending more time understanding anytime asking managers asking for head count, why they would need that, how can we not do that? And so yeah, we're a lot more intentional about it now.
Great. Just looking at the time, 6:45, I think we'll stop here. And then we'll have about another 45 minutes, an hour of just kind of networking, get to know each other. Well, Amjad, thank you. This was great. Learned a lot. Okay, thank you.